Hello everyone, welcome to Beyond School Maths by Tech Lead. One challenging problem, one clear solution. Let's take a look at today's question. It says if x is a non-negative real number, find the minimum value of this expression. All right, so whenever you see the sum of square roots like that, and whenever you see x squared plus something, you should think about the distance formula first. Don't try to solve it by algebra. It'll be time taking and maybe it doesn't even end up in a real solution, right? Okay, so now see, the first expression is simple. It's just x squared plus 2 squared, right? The second one I can write as a completed square form because I'm trying to think in terms of distance formula, correct? Okay, now to make it a completed square, what do I add? Half of 24, which is 12. So I add a 12 square and I subtract a 12 square to this expression. So plus 12 square minus 12 square. That makes me what? My expression becomes x square plus 2 square plus 12, sorry. So it becomes 12 minus x whole square plus 153 minus 12 square is 144. That makes it a plus 9. Or you can replace the 9 with a 3 square, right? Okay, now whenever you see something like root of a squared plus b squared, we know what the Pythagoras theorem is, right? It says if the legs of a right angle triangle like this, if they are a and b, so this is the hypotenuse, correct? So a squared plus b squared is equal to h square. So the Pythagoras theorem states that h square is equal to a square plus b square, or this hypotenuse length is equal to under root a square plus b square. That's exactly my form. Here also and here also, right? Now let us interpret in terms of geometry. So if I make right angle triangles like this and call it say A, B, C, D and E. So now looking at my expressions here, which were x square plus 2 square. So the smaller one I can call this x, I can call this 2. Now see, if I see the other expression, it was what? 12 minus x whole square plus 3 square. I can take the same base, right? Because 12 minus x plus x is 12. So if this entire distance was 12, this can be 12 minus x. And this is 3. These are my right angle triangles, right? So if this is h1, this is h2. This is h1 and this is h2. We need to find the minimum value of h1 plus h2. Correct? That's what our requirement is. All right. So now what do? So I know distance between 2 points is minimum when it's a straight line. It's linear, right? So can I think about reflecting this distance down? So if I reflect this down, I make it c dash, and reflection preserves distances. So distance will not change. This a c dash will be 2 again, and c dash b will be h1 again, right? Now for this distance to be minimum, it should have been a straight line, right? It should be linear. So now when I make a right angle, big right angle triangle, if you see this distance here is how much? 5, because this was 2 and this is 12, we know. So by Pythagoras, it should actually be 13, because see, if you know what are Pythagorean pairs, so you should know 3, 4, 5 is a Pythagorean pair, because 5 square is equal to 3 square plus 4 square. Similarly, 5, 12, 13 is also a Pythagorean square. So even without calculating, we know that if the legs are 12 and 5, this has to be 13. So the minimum value is 13. That is our answer, right? Okay, so this problem could also be tackled by Cauchy Schwarz inequality, right? Now, what is Cauchy Schwarz inequality? It states that if there are any real numbers a1, a2 up till an, and suppose another set of real numbers b1, b2 up till bn. So my Cauchy Schwarz states that if I square a1 square plus a2 square plus an square times b1 square plus b2 square up till bn square, that will always be greater than or equal to a1 b1 plus a2 b2 plus an bn whole square. That's my Cauchy Schwarz. Another way of writing it, take the root. So I can just take root of this side should be greater than, I will remove the square, a1 b1 plus a2 b2 plus an bn, right? And here it's the same thing. So now if I look at my expression, right, what is my s? S was given as x square plus 4 plus, I wrote it as a completed square form, plus 9, right? Okay, now to use that, I need a multiplication of two numbers inside a root, right? So let me just square it. If I square it, I will get what? A square plus b square plus 2ab. So x square plus 4 plus 12 minus x whole square plus 9 plus 2 under root x square plus 4 times 12 minus x whole square plus 9. Right? Now, as per my Cauchy Schwarz, this expression here, this rooted term should always be greater than a1 b1 plus a2 b2 plus. So, what is a1 here? a1 is x, a2 is 4, b1 is 12 minus x, and b2 is 3 because it's 2 square and 3 square. All right. So, now let me apply. Now we know by Cauchy Schwarz that this expression here, x square plus 2 square times 12 minus x whole square plus 3 square should always be greater than or equal to a1 b1. So x into 12 minus x, right? Plus a2 b2. a2 b2 is 6. 2 times 3 is 6. All right. So now we know s square. Now see, if this is always greater than this, then s square will be greater than equal to what? I can replace this by this. So x square plus 4 plus 12 minus x whole square plus 9 plus 2 times this. I hope that's clear, right? Suppose s square is something. Suppose this expression was 4. All right. So root of 4 is 2. That means s square must have been greater than this number plus 4. Now, since this is always greater than this, if I take a number lesser than this, then s square will be always greater than this number put in this expression. I hope that's clear. All right. Now let's simplify. So s square, just expand the terms and nothing else now. So x square plus 4, apply a minus b whole square here, 144 plus x square minus 24x plus 9. Simplify this inside. This becomes what? Plus 2 times 12x minus x square plus 6. Right? So now see, it should always be greater than x 2x square. I'm counting these 2x. Then what do we have? We have minus 24x, and this is what? 140. Let me leave it like that. So it's 4 plus 144 minus 24x plus 9 plus 24x minus 2x square plus 12. So see, minus 2x square cancel. Minus 24x plus 24x cancel. Now you just have to calculate all this, right? So this becomes what? 12 plus 9 is 21. 21 plus 4 is 25. So 144 plus 25 is 169. So s square has to be greater than 169. Therefore, s minimum value is what? 13, because 13 square is 169. So you can also do it by this method. I hope it helped. Also, now for the equality, remember I put this equal sign. For the equality, Cauchy Schwarz states that what should happen? A1 by B1 should be equal to A2 by B2 and so on. So now if I have to find the condition when it will be equal, I can just say x over 12 minus x is equal to 2 by 3 and solve it. So 3x is equal to 24 minus 2x. So 5x is equal to 24. So x is equal to 24 by 5, right? 5.8. So at this, you will get the minimum value. Hope it helped. Thank you so much. Bye-bye.